Hi friends. So in this video we are going to learn about the circular doubly sync linked list. Okay. We have already seen about the singly linked list and circular singly linked list and also about the doubly synced list. Okay. So here we are going to learn about the circular doubly linked list. Okay. So let's see how we can do this. Okay. Let me up this. Why it's not working? Just a sec. Okay, so in circular doubly linked list, we have this nodes. Let's say we have this node, first node, then we have this second node, and then we have this third node. Okay, so for it will be having two pointers, one pointing to the previous node and one pointing back and other pointing forth. Okay, so now we have let's say data here 20, 10, 20 and 30. This has the address 100, 200 and 300. We have the head pointer here. So the above diagram represents a doubly linked list, right? So this is null, this is pointing to 200, this is 100 pointing back, and this is 300, then again this is 200 and this is null. Now this two pointers, the previous of the very first node and the next of the last node, contains the null pointer. But if we talk about the circular doubly linked list, we don't have here the null pointers. Okay, so this will be pointing somewhere to the first node. Okay, so this way. Hence, it will be updated with the address 100. Okay, that is the head. And the head, previous of head is pointing to this last node. Okay, this two-way, because we have this doubly linked list. So here we need to have the updated pointer as 300. Okay, so this is now fully complete. So this is circular doubly linked list. Now definitely we are just updating the two pointers of the first and last node. But now if you see, if we have reached at the last node, we can come back to the first node. And now if we have here the last node address and we have to delete the last node of the linked list, we don't need to traverse. We just have the address here. We can just go to the last node and update it. So in this way, it has some advantages over the existing doubly linked list, right? So the first node previous will point to the last node, and the last node next is going to point to the first node. Okay, so let's see how we can perform the insertion. So if we have inserting at the beginning, or we have to insert at the end, so definitely it has become now easier. So for the end also, we just need the previous of the first node, and we can update, go just to the last node and update the pointers at the end. We don't need to traverse the entire linked list. And even if we have to delete the beginning and the end, we don't have to traverse here up till the last node. Okay, so the deletion and updation, insertion at the beginning and end has become easier, okay, with the updated pointers, right? Also, there is one thing to note that in the single linked list, the time complexity for insertion and deletion in the average case is order of n. So if we look at a singly linked list, so the order of insertion and deletion are time complexity for insertion and as well as deletion is order of n for the average case, right? So to improve this to order of 1, that is constant, we can use the skip list. It comes under advanced data structure. We are going to learn a few lectures ahead. but I would like to tell you about this, so I have added. So this was about the circular doubly linked list. So the insertion and deletion are easier now with the updated pointers. We are now going to see some of the examples of the linked list and solve them. I would try to suggest you that if you want to learn more on this linked list, you can just refer to some of the programming languages, and you can just using those languages you can just create a singly linked list or a doubly linked list and perform the operations like insertion, deletion at the end, insertion at the end, and so on, that we have already discussed, to give you an overview of how this exactly works when we program the things. Okay, so that's it for the lecture, and keep watching. Thank you very much.